Welcome back to the Fire Break. I'm Steve Wolf. As you know, the Fire Break is sponsored by Team Wildfire, where we're developing innovative ways to put out wildfires, or at least push them away from the things we don't want to burn using jet engines on trucks. Pretty cool stuff. Check us out at teamwildfire.com. So today, what are we going to talk about? We're going to talk about what's going on in visualization of wildfires, right? Before you can put something out, you have to understand it. And generally, to understand something, you got to see it. I've got Jonathan Bowers with us today. And Jonathan is working on some pretty interesting visualization and predictive modeling software up there in Canada, the nation that can't keep its smoke to itself. Jonathan, welcome to the Fire Break. How are you?
I'm great. Yeah, we're our chief export, maple syrup and wildfire smoke in the summer.
Yeah, very nice. Very nice. So tell me what you're working on.
Yeah, we are working on I think you explained it quite succinctly. It's a platform that enables organizations to simulate wildfire in the cloud.
Okay.
It uses
Now,
weather data.
wildfires in the cloud are called like pyronimbus clouds, right?
Yeah, there's
Okay.
cumulopyronimbus, I think.
Yeah, that's right. So that's
I'm not,
cloud-based fire.
I think so. I'm not a weather guy, but I've started to pick up some of the terms, and
Okay.
I do occasionally catch a glimpse of some things and then tweet about it and ask some of the wildfire specific folks if this is in fact what I'm looking
If
at.
it's right. Did I get any of this
Yes.
right?
Yeah.
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 All right. But you're doing like a cloud-based platform, is that right?
Yeah, it's a cloud-based platform. It takes in fuel data, weather data, runs them through open fire growth model algorithms, spits out some kind of risk and fire behavior pattern. So you'll see fire spread, fire severity, fire intensity, crown fraction burn, stuff like that. So the goal being that users of the platform can very quickly essentially just point and click on a place on the landscape and within minutes get back a deterministic output of what the models think the fire would do on that day given the weather forecast.
Okay. And what does it know about the current conditions and the current fire size and location?
Yeah, so the models actually the ones that we use, the current model that we have, Prometheus, which is a model that was developed in Canada, really doesn't have a sense of what the current fire is. It also doesn't model fire suppression efforts. So it essentially assumes an ignition point, and given the fuel and the weather around that ignition point, what is it going to do? And then it simulates a fire over a certain period, say 12-hour burn period.
And that would be, so that's the old software, right? That's Prometheus.
Yes. Yeah.
And that it didn't include mitigation efforts and how they might impact the fire.
No, I don't believe a lot of the models do. A lot of the models, including Prometheus, don't account for a lot of things. Ambercast. They sometimes over index on bodies of water. Last year we saw near our town in the Lake Okanagan, the fire jumped the lake, 2-kilometer lake, and those fire models don't really account for that. Don't really model that kind of behavior.
It's like
I think
there's Fort McMurray fire, it jumped the lake also, right?
Yeah, I don't recall there. I was talking with another gentleman out of Colorado a week ago or so, and he said one of the fires jumped the Continental Divide. I'm not sure if it was last year or the year before, but there's this fire behavior is becoming quite extreme and quite difficult to predict.
So are you saying that maybe digging out a 4-meter trench between two bodies of woods might be insufficient?
I mean, again, I'm not a fire expert, but in some cases it doesn't seem like it is, especially if it's jumping lakes. I mean, that's a big distance. Pretty hard to fight. That's
not a reason not to put 4,000 guys with shovels up on a line, though, right?
Yeah.
Right. Okay. So how are you modeling differently? What have you incorporated in? Like, where did you pick up where Prometheus left off and then build on it?
So we're still using the Prometheus model under the hood. What we've done is automate the process of actually getting all the data together to feed it into Prometheus, and to make it very fast and responsive to getting some of those results. So typical fire simulation might take, half an hour to an hour to actually gather the data, get it ready for something that you need to, in a format that you need, feed it into a model like Prometheus, get the results back out, and these would be raster files, and then you'd send that off to some GIS person to incorporate into whatever GIS platform you need to use to visualize it, and that can take several minutes, potentially hours, to do, and it's a little bit labor intensive, fairly occasionally error prone. There's a lot of knobs and dials and things you've got to twist and turn in order to get the results that you're looking for, and some expertise in understanding how to do that. So our platform automates all of that. So the fuel data, we pull down fuel data from wherever we can get it or wherever a client might tell us is important to get it. Weather data, we pull down weather forecast models. Currently, we use 2 models, but we can essentially pull down any weather forecast model. We get an hourly weather stream and feed that to Prometheus. Execute Prometheus, which is not a simple feat, because it's essentially an old Windows software that we've figured out how to turn into cloud-based software, take the outputs of that and then present it on a map. So sort of the whole cycle essentially takes 2 minutes, and it's just a case of clicking a ignition point and running a simulation, and then you get the results back relatively quickly.
That's pretty cool, John. So you're a startup. What's your company called?
Our company is called Path and Focus. We're a startup. We've actually been around for a number of years now, kind of just in the background, evolving this platform a little bit. We started off doing something similar, but in a different space for the forestry industry. We leveraged some of the work we had done with weather data and weather aggregation in public safety with avalanche forecasting, moved that into wildfire stuff, and then helping specifically BC forestry companies automate the compliance with wildfire regulations and when they can and can't work out in the bush based on the fire severity. If it's too high, the risk is too high, so the government says you can't be out there running your saws and equipment. And so we help them understand if they can or can't do that today.
We can put robots out there.
Well, yeah, no, I don't know about robots. It's really just don't want the sparks. It's any kind of equipment that can start a spark. They don't want those out on hot, dry conditions.
Windy days, right?
Yeah.
So, okay, so you're doing fire modeling, predictive behavior work as a software startup, essentially, and it's kind of a crowded space, right? I could name half a dozen entities that claim they're doing something similar. So how do you distinguish yourself? What's as unique about what you're doing?
Yeah, that's a great question. We typically don't pay a ton of attention to the competitors. I mean, it's useful to know what they're up to and what they're doing. We try to focus mainly on what customers, or we're pre-revenue, so what potential customers are looking for, and we've had some really interesting discussions with some customers or some potential customers. And the thing that we're really focused on is democratization of these tools. So we don't have a model of our own. We don't think that that's really the avenue that we want to go. We want to be a platform that enables any model to run. So if we find a customer that has very unique circumstances and they have a particular model that they want to run, we can incorporate that. We can also incorporate customized risk calculations on the other side. So once we've run a fire growth model and produce rasters that show fire behavior, we can interact that with other GIS layers of say infrastructure, homes, land use, to try and quantify the risk of that fire. So if it's going to basically just burn down some grass and not really touch any homes, might be lower risk, where if it's going to potentially affect a town or homes or a hospital, elevate that risk. And so we can build custom calculations there. And then the other thing I think that we tend to focus on is usability and extreme ease of use. We want things to be fast, to be easily understood. We don't want people to have to go through, a degree to have to use our software. Ideally, a quick 10-minute video, 20-minute video, and you'd understand the basics on being able to operate this thing, and at scale.
And so getting the process of your raster files to export more quickly, that would be an app called the Velociraptor, right?
Yeah. I like the puns that you that you come up with. Yeah, but the goal is, like, we think that, just speed of access to some of these tools and ease allows people to do more and focus on the things that they're good at. I mean, nobody wants to be good at tweaking software.
You do, I hope.
Guess, yeah, well, yeah, that's true.
Right,
I do.
right.
But we want to enable people to be able to focus on a thing that they're valuable at, and that they bring, the skills they bring to the table, and on interpreting those results, acting on those, making decisions that affect communities or property, and just allowing them to have more information rather than being selective about what types of information that they want to use, because it's so expensive and time consuming to create.
Is this something that anybody could use, or do you have to be in the fire service? The fire service is a pretty small band of people with a pretty homogenous thought pattern.
Yeah.
And I would think that if we're going to see some really, unique approaches to fire management, we want to really democratize that beyond the fire community, so that some brilliant little 8th grade kid sitting in BC could play with your software and have some revelation that could change the way we think about wildfire.
I love that idea. I mean, I won't proclaim that was me, sitting in 8th grade, solving the world's problem, but certainly, sitting in 8th grade, having interest in things, interest in data, and being able to access that. I like that. Thank you. I think that's a great potential outcome. But to answer your question, yeah, we don't think that this should be purely the tools of the experts. I don't think we're in a place where we can really give this to everyday folks. There's still a lot to learn and understand about fire in order, I think, to make any useful decisions. But that being said, I don't see the possibility of putting this in the hands of individuals as out of the question. Like, I do think that's something that's possible. We have another tool that we built, Lens, which is intended for everyday people to be able to use. It's a free tool. It lets people come in and look at hotspots. So satellite detected hotspots of wildfire for Canada going back at least a decade, maybe longer. I can't remember the start of it. And again, it's something that's very, very fast. You can really quickly look at the landscape or your backyard and see what fire has done in the past, or if there's a fire going on right now, what is happening? What did it do yesterday? How did it grow? It's a very interactive tool, very very dynamic, very exciting to look at. Maybe to some degree not exciting in the right way if there's a fire in your backyard, but certainly an interesting tool to look at. And that's something that we continue to try and build upon, is some of the tools that enable the general public to just understand what is going on in this world that we find ourselves in.
I would imagine having access to that historical satellite data is the best way to validate the accuracy of your software, right? You put an XY on a map and say the fire starts here, this is what it's going to do. Then you pull up historical images of a fire that started on that same spot and see if that's actually how it behaved.
Yeah, I mean, the models have already more or less been validated, but still, like, we're looking for ways to validate some of the other methods that we've come up with, including sort of doing a more ensemble approach to fire modeling. So taking multiple weather streams and potentially multiple fire models, and like doing just a Cartesian join of these things. That's a database term, but like mix them all together and see what kind of results we get, and then create a bit of a probabilistic output. We'd be really curious to explore how well that validates against the past truths.
And is there any capability for some IFTT in there? If we do this, then the fire will do that. And, because if you look at it, right, you could say, oh, the fire's heading here. We'll, chop down some trees here. Or we'll lay out some retardant there. Or we'll do an aerial bombing run there, right? But how do you know whether those things are going to be effective? Well, I guess you just go do them, which is expensive in materials and lives. So to what degree could we gamify the suppression effort and see if we do this, then, right? Can you do that?
I think that could be a use case. I mean, again, we're a bit early, so I don't know. I don't have a story to tell you where that's been successful, but that's a goal for sure. And I think a lot of it is, these agencies that are doing fire suppression don't have a ton of time or resources to make those decisions.
Right. Wait, they have time to go do something, but not to evaluate whether what they're about to do is the right thing?
Well, I mean, I just think that just with anything, right? There's so little time and just not nearly enough. I mean, they're well resourced, but still we could put more resources in play. How do we make their time effective? How do we make it more, more likely that they're actually seeing all the information so that they can prioritize their efforts? So allowing an analyst to be able to run thousands or hundreds of thousands of fire simulations within an hour to get back a sense of, okay, here's where the risk is most prominent. Let's focus in on that area, ignore some of these lower risk areas, or maybe not ignore, but sort of deprioritize those, focus on the high risk areas, start to run, put some more closer eyeballs, get the looking glass out and really dig into it and decide, oh yeah, this is something that we should do. Here's how we should react. Here's precisely where we should react. And it's based more on data that you can use to back it up. But making those decisions quickly, the beginning of the day rather than the end of the day,
right?
Could potentially
and during the day.
Yeah.
Right, because fire conditions are dynamic and always changing, and wind conditions are changing, and humidity changes, and the ability to input that data and get new visualizations during the day, I think would be very valuable.
Yeah, one of the things that we're starting to explore, and it's based on some feedback from some early potential customers, was the desire to model weather that even the forecasts haven't really predicted. So fire drives its own weather, and all of these predictive units within fire suppression agencies have forecasters. They have weather forecasters who will go in and sort of look at the weather that the model has produced and adjust it and say, yeah, we don't think this is going to happen. We think it's maybe going to be even hotter, or the wind is going to be more intense based on the fire behavior, based on whatever context that they have, creating scenarios for weather to feed into these models to say, okay, let's imagine that the weather is 25% worse or whatever. What's it going to do there? Enabling that kind of rapid execution of scenario to model output is something that we're really interested in exploring and trying to enable. And we've got some ideas around how to make that happen.
Okay. So when you're pulling, data from current weather, or the Weather Service is doing that, what is the density of input sources? I would imagine that in some of these remote areas of Canada, the nearest weather station might be 200-300 kilometers from where the fire is. And so you're looking at, very accurate data for a point that has very little to do with where the fire is. It just happens to be the nearest point.
Yeah, that's even less extreme than that. Even in more dense areas where there are weather stations that are relatively close together, sometimes the location that you're concerned with is at a completely different elevation or in a completely different biogeoclimatic zone, and that nearest weather station isn't appropriate. So trying to figure out which weather station to use is a challenge for sure, and that's something that we haven't automated, but we've built in so that the analyst can pick and say, oh, I know this region. And a lot of these folks that are operating these tools, whether it's something like ours or Prometheus or whatever tool that they're using, they have a deep understanding of the landscape, and they've got their little local knowledge and nuance. And so they'll know that, if the fire's over here at this aspect, that weather station that's on the other side in the valley isn't appropriate. I actually need to use the one that's a little further away. So we enable that kind of capability. But we also, in order to do the prediction, we actually pull down the weather forecast. And so that we can get for any location, regardless of whether there's a weather station there or not. And so we pull that down on demand, which is also quite a feat.
Right.
And the so the density of that is basically as dense as the forecast model gives us. Sometimes that's at 2.5 kilometers. Sometimes that's 10 kilometers. Sometimes that goes out as far as 10 days. Sometimes it only goes out as far as 3 days. And so we've got to pull all that stuff down and give you as close a picture as we can to what the reality is going to be. One of the interesting things that we've found through analyzing some of the data, and it's still sort of early on in our understanding of this, is that the weather forecast is actually a pretty good predictor the closer it gets to the day. And that actually sounds intuitive, right? Like the farther out, the weather forecast, I mean, we all know this, what's the weather going to be like on the weekend? Oh, sunny and warm. And then turns out it's, like cloudy and rainy. But the weather forecast for an hour from now is actually pretty accurate. And so, even just using that weather forecast for a location that's nowhere near a weather station, we think is decent analog.
Decent enough.
Yeah.
Right. I see.
And in the absence of information, some information we think is better.
Okay.
Yeah.
So are you putting your XYs in there for active ignitions, or is this just allowing people to, pick a hypothetical ignition point? And
right now it's a hypothetical. So you would point and click, drop a point down and say, imagine a fire starts here. What's it going to do? Imagine a fire starts in any number of these locations. So we support any number of ignition points. We also, from the perspective of like a municipality or a community or a corporation that has infrastructure, you can create ignition points that are static. And
if this power line goes down.
What damage could it do if it sparked a fire? And so we set these ignition points, and then every day we can simulate those with like today we get the weather and then run a simulation.
A company like PG&E or something, they probably know which are their most likely power lines to go down, and on any given day they could model out what the consequences of that dropped power line would be. And then they could amass their resources, hopefully not need to deploy them, but at least they'd be amassing them in the right spot so that if something did happen, they're ready.
Yeah, no, that's absolutely the goal, is that those kinds of organizations can understand the risk on a day-to-day basis. And then for strategic planning, we can run some of these simulations using just historic weather and projected weather to come up with a more probabilistic output, for the year. At the beginning of the year, here's where we think things could be bad if a fire were to start here, based on the, we simulated a fire every day from May 1st to September 31st, September 30th, and
it's right after February 30th, right?
Yeah. Here's where the risk is this, this area, this corner of your property here, corner of your infrastructure, this is highly exposed. There's a lot of values at risk there, a lot of fuel leading and prevalent wind that is going to take a fire right to a community. Here's what the probabilistic output looks like. And then they can make some decisions, maybe bring some jets on trucks and blow a bunch of that stuff away. And
I hope so.
Yeah.
Very, very interesting. So what are the biggest challenges that you're facing right now?
I mean, there's so much to do. Like there's there's a lot that we want to do. Prioritization is maybe one of the challenges. There's so much that we both know we need to do and that we want to do, and some things that we haven't really discovered yet. We know we can do it though. Like we know we can build the thing that we need to build. In fact, we've built it.
Right.
And so, one of the challenges, and you've sort of hinted at, is how can we democratize this further? How can we put this sort of down into the hands of more and more people so that they can benefit from some of that data, and at a cost that's not prohibitive, right? Like there's
right.
These large suppression agencies, governments, they have a lot of funding, and they have access to money, right? It's not like they can spend money at this kind of thing. They're probably their biggest resource constraint is time, at least when it comes to some of this modeling.
Sure.
But for a small organization, it's both time and money and expertise, and so we want to try and bridge all of that if we can. And I think that's a challenge, but it's a moonshot that we hope to be able to accomplish.
And how close are you to something that you want to put into beta?
We're very close. We could essentially, for a certain type of customer, be ready to go tomorrow.
What time?
There's 10:15 a.m. tomorrow. Yep. There's obviously a lot of work to do on the edges around satisfying some of the nuances and all the sort of weird requirements that certain customers might have. But on the whole, if an organization needs to simulate fire every day or even on demand whenever they wanted, we could do that tomorrow.
Very, very interesting. What percentage of the land mass of the planet is incorporated into your system now?
Oh, yeah. So that would depend on who the customer is. So right now we have BC and Alberta fuel. We deliberately truncated the fuel to just include that, just because it's cheaper. And but for if a customer were to come from somewhere else on the planet, as long as we can get the fuel data, we would be able to work with that.
And what's your source for your fuel data?
Again, it depends on the customer.
On the country.
So the Canada itself publishes a fuel grid that we use as a base. And it's open, it's free data, it's open data. So we use that. Some of the local governments, the provincial governments, have their own fuel data. So we will pull that, also open. There's a number of companies that have proprietary fuel data that, say, a municipality or an indigenous community can access and purchase, and we can incorporate that in as well. So it really depends on what the customer wants to do, but we have a base of the national fuel grid from Canada that we use.
Okay. And so are you prioritizing your fuel model acquisitions based on the financial opportunities in each location?
Yeah, essentially. So if we know some of the utility customers will use private data, and they might even have their own fuel data that they've acquired through aerial or drone. So we can incorporate that. But essentially, if a customer wants to use the tool, we'll figure out how to pull fuel in for them.
Okay. So very interesting.
Yeah.
And so you could pull their fuel data, but still run it into your model, because their fuel data might not be connected to an effective predictive model.
Yeah, we'd probably have to work at conditioning the data to work with what the model is expecting. So, for example, Prometheus works with the FPB fuel types. Here in Canada, there's 16 fuel types, and that's pretty coarse. Other models might use different fuel in a different way, so we would have to map the fuel data into whatever the model is expecting. But that's something we're fairly confident that we can do, again, depending on the data.
And then at some point, the data is self-cleaning, right? That the the model recognizes what the format of your data source is and works accordingly, instead of you having to clean it up to meet the model's needs.
Yeah, I mean, we wouldn't want to clean the data every time, right? Like we would set up automated mappings that,
Right.
If fuel is classified in one way in one data set, we say, oh,
Interpolate this way.
that type gets classified like this for
Right.
the model to use, so that as that fuel data gets updated, if they've gone and acquired newer data, because this stuff
Right.
changes. I mean, it
Yeah.
hopefully doesn't change that much, but stuff burns, and right, like,
Right.
so yeah, or there's some mitigation effort or something, so there'll be some fuel load reduction. So we'll try to incorporate that in. Essentially,
right. You don't want to have to write a new dictionary every time someone speaks to you in a new language.
No, exactly. Yeah.
Yeah.
No, that would be
like, oh, you're French, huh? Got it. Which could happen up there, right? And
yeah. We have some French people up here.
That's great. Well, absolutely fascinating what you're working on. I hope that we can reconnect within a few weeks or month, and you can tell me about the progress that you're making.
Yeah, I'm excited about it. I'm also excited to see if we can incorporate some big jet engines on the back of trucks, because I think
well, what would be useful for you is not only maybe being able to model what different retardant application areas would be, but to have a weather station on board the machine that's sitting right in front of the fire, and then you're getting absolutely local data. So that's one of the things we wanted, is put weather stations on the trucks and uplink them so that services like what you're doing have actual. This is what the weather's doing, 2 meters from the fire.
Yeah, I mean, if you have data, we can put it on a map pretty quickly, and with some really nice ways of interacting with it. Whether that's a weather station on the front of a truck, or a weather station that's been permanently installed somewhere, or remote sensed satellite acquired data, we can map it and make it
put it all
very
together.
fast access. Yeah.
Very, very interesting. Well, I'm going to watch. Hopefully you'll send me one of these 10 or 20 minute instructional videos, and then I'll tell you how many years it takes me to figure out how to do it.
Yeah. Okay.
Hey,
deal.
Jonathan, thank you so much for joining me on the Fire Break today. It was really great chatting with you.
Yeah. Thank you so much for having me. It was a pleasure.
Absolutely. Any new news comes up, ping me, and we'll get it out to our listeners and viewers right away, because they're desperate for good information. It sounds like you're generating some. Again, Jonathan Bowers joining me here on the Fire Break. Thanks so much for listening or watching. I hope watching, because, guys as good looking like as we are shouldn't go to waste, right? Yeah.
No, you got to come check out these faces.
Yeah, exactly. All right. The Fire Break is sponsored by Team Wildfire, developing innovative technologies for wildfire suppression, fire ground services, asset protection, and stuff like that. Check us out on the web at teamwildfire.com, and check out Jonathan Bowers. Jonathan, you want to plug your website one more time?
Yeah, pathandfocus.com.
Great. All right. Thank you so much, Jonathan. Thanks so much for listening to the Fire Break, and we'll see you at the next one. Take care.
Bye now.